Welcome to the Future Lab, the podcast exploring the frontier of autonomous science. I'm your host, Matthew, and today we're diving into a groundbreaking research paper, Autonomous Chemical Research with Large Language Models. This paper details Coscientist, an AI system that autonomously designs, plans, and executes complex chemical experiments. We'll explore why this is a significant leap forward in automated science. Autonomous science is revolutionizing research by automating processes traditionally done by humans. Think about it, we're talking about robots and AI working together in the lab, optimizing reactions and synthesizing molecules, all without direct human intervention. This paper shows how large language models, specifically GPT-4, can make this a reality, and it's not just about speed. This is about opening up entirely new avenues for scientific discovery. By automating tedious tasks, researchers can focus on the most creative and challenging aspects of their work. It's incredibly exciting, and as a testament to the advancements in AI, I should mention that this episode's script was partially generated with the help of an AI language model itself. Kind of meta, isn't it? So, what exactly did this research achieve? To give you a roadmap of the episode, we'll begin with an overview of the Coscientist system's architecture, then delve into its methods, discuss its applications, and finally, wrap up with key takeaways and look towards the future. Let's get started. So, let's get into the heart of this research paper, published in Nature. It introduces Coscientist, an AI system developed by a team at Carnegie Mellon University, led by Daniil Boyko. What's so special about Coscientist? Coscientist uses GPT-4, a very powerful large language model, to autonomously design, plan, and perform complex chemical experiments. This is a huge step forward. Before Coscientist, automated lab systems were really limited in their ability to plan experiments. They could execute pre-programmed steps, but they couldn't adapt or come up with new strategies. Exactly. That's where Coscientist shines. It bridges the gap between these powerful LLMs, like GPT-4, and the physical world of the chemical laboratory. It's about bringing the power of AI reasoning into automated chemical synthesis. The core idea is brilliantly simple: use a large language model to plan and execute complex experiments. But the results are anything but simple. The authors demonstrated Coscientist's versatility across 6 diverse tasks, including something as complex as optimizing a chemical reaction. And that's the key finding: they proved the effectiveness of LLM-based autonomous chemical research. Coscientist isn't just a theoretical concept, it's a working system that's successfully tackled sophisticated chemical challenges. This is a game changer. So, how does this AI actually achieve these advanced capabilities? Let's delve into the technical details of Coscientist's architecture. That's where things get really interesting. Now, let's get into the nuts and bolts of how Coscientist actually works. At its core is GPT-4, acting as a central planner agent. Think of GPT-4 as the brain of the operation. This planner doesn't work in isolation. It interacts with several other modules, one for web searching, another for executing code, and a crucial one for automating experiments using application programming interfaces, or APIs. The whole system starts with a simple text prompt, something like, perform multiple Suzuki reactions. The beauty of the system lies in its simplicity. The planner uses 4 core commands: Google, Python, documentation, and experiment, to interact with these different modules. It's a remarkably elegant approach. Let's break down those commands. Google leverages another LLM to search the internet for relevant information. Python executes Python code in a secure, isolated Docker container, very important for safety and reproducibility. The documentation command accesses and summarizes information from the relevant APIs. And finally, the experiment command is where the magic happens. This is how Coscientist interacts with the real-world lab equipment. The researchers use 2 different platforms, the Emerald Cloud Lab and the OpenTrons OT2. This allows for flexibility and validation across different robotic systems. The real innovation here is the seamless combination of LLMs with these various tools. It's not just about automating individual steps, it's about creating an intelligent, adaptable system capable of planning and executing entire experiments. Of course, it wasn't all smooth sailing. Integrating an AI with physical experiments presented significant challenges. Ensuring the reliability of the code generation and execution was crucial, and I imagine debugging those interactions was quite the undertaking. Despite the complexity, the paper is actually very well structured. By breaking down the system into these distinct modules, the authors make the whole architecture remarkably clear and easy to follow. This makes it accessible to a wider audience, not just AI or chemistry experts. Now that we understand the system's architecture, let's explore its capabilities in more detail. So, what are the practical implications of all this? What can Coscientist actually do? Coscientist isn't just a theoretical exercise, it has real-world applications across many areas of chemical research. We're talking reaction optimization, synthesis planning, and even materials science. Think about reaction optimization. Traditionally, this is a painstaking process of trial and error. Coscientist can automate this, significantly speeding up the process and potentially leading to better results. Exactly. And it's not just faster, it's also more efficient. Coscientist can run experiments around the clock, significantly increasing throughput. This is especially valuable for large-scale screening or optimization projects. This has a huge impact on the field of autonomous science. It demonstrates the potential for LLMs to actually drive scientific discovery, pushing the boundaries of what's possible in AI-powered labs. It's not just about automation, it's about the level of autonomy and explainability. Coscientist doesn't just produce results, it provides a clear and understandable trail of its decision-making process. This is crucial for both reproducibility and ensuring trust in the results. Let's paint a picture. Imagine a lab where robots, controlled by Coscientist, synthesize new molecules based on simple text prompts. Or imagine it automatically optimizing reaction conditions by iteratively running and analyzing experiments, learning and improving with each iteration. This research is groundbreaking. It's incredibly technical, but the implications are absolutely profound. We're talking about creating truly autonomous labs, capable of making scientific discoveries at an unprecedented scale and pace. And that naturally leads us to our final section, a discussion of the key takeaways from this work and what the future might hold for autonomous labs. Let's recap the key takeaways from this fascinating research. Coscientist, at its core, uses GPT-4 to autonomously run chemical experiments. It does this by cleverly combining web searches, code execution, and those crucial lab automation APIs. And the results? Coscientist demonstrated real success in optimizing chemical reactions. This represents a genuinely new level of automation in scientific research. We're not just talking incremental improvements, we're talking about a fundamental shift in how chemistry experiments are conducted. The researchers' conclusion is clear: LLMs can effectively control lab equipment to perform complex experiments. This drastically accelerates the pace of chemical research. It's no longer a matter of if, but when, these kinds of systems will become commonplace. But this is just the beginning, right? This is not the end of the story. The future outlook is incredibly promising. Further advancements in LLMs and lab automation will inevitably lead to even more powerful and capable autonomous labs. We can reasonably expect to see a surge in AI-driven scientific breakthroughs across various fields in the near future. This research opens doors to a new era of scientific discovery, and it's breathtaking to contemplate the possibilities. Thank you for tuning into the Future Lab. This episode showcased the revolutionary potential of AI in scientific research, specifically within the realm of chemistry. The implications are far-reaching and profoundly impactful. Join us next time for another exciting exploration into the world of autonomous science. Until then, stay curious. You've been listening to the Future Lab.